Now, let's have a look at the time and window mechanism for flink, which is key point in this chapter. Firstly, why do we say time is important for flink? Actually, time is not only important for flink, but also important for all stream processing computing engines and frameworks. Because stream processing is basically event-driven, and events are ordered by time. That's why time is vital for stream processing engines. Ideally, we need all events ordered by their generated time, and in the computing engine, the event time is represented by the system time of the server. However, due to some reasons like the network delay, the system time is not exactly equal to the event time. So in fact, there are three types of time in stream processing. The event time, which is a time when the event is generated. Ingestion time, which is a time when the event is caught by flink server. Processing time, which is just the system time when event is analyzed or processed by the flink system. And once again, ideally, we assume the three different types of time are equivalent. But in actual cases, event time is earlier than ingestion time, and ingestion time is earlier than processing time. Therefore, if we just focus on the comparison between event time and processing time, naturally, we can draw a graph like this. In ideal cases, they are equivalent, so a straight line with a tilt angle of 45 degrees is expected. But owing to the time delay, the processing time is always later than the event time, while the latency is stochastic or random. That is why we can see an irregular curve here. Maybe I can show you an extreme case like this. Okay, so in this extreme case, the first event, okay, maybe this is the first event and this is the second event. Okay, so the first event happens before the second one, but the processing time of the first event is somehow later than the second one. And this is common, but not normal, and we call it out of order. And to deal with the out of order situation, we need a mechanism called watermark. We'll introduce it later in the third chapter. Here, you just need to know its name. But firstly, it is necessary to introduce the window mechanism. As we introduced before, for batch processing, the dataset is finite, so we just need to make analysis based on all the data we have, and that is called a global window. But for stream data analysis, the data stream is unbounded, and we know that we cannot do statistical analysis based on infinite dataset, and it is meaningless. So we need to split the infinite dataset into several buckets, and in each bucket, the data is finite. This method of splitting is just the window mechanism. And based on the different application scenarios, there are two main types of windows, the count window and the time window. Literally, the count window is data-driven, and each window has exactly the same number of events being considered. Namely, we only care about the number of events occurred in each window. And as for the time window, each window is determined by a time period, no matter the time period is defined by the window length or the mechanism time interval between two windows. It is easier to understand the count window, so next we are going to introduce the time window in details. And actually, there are three kinds of time windows: the tumbling window, sliding window, and session window. So we will introduce them one by one. The first window type, tumbling window. In this case, the windows have exactly the same length, and they are adjacent but never overlapping with each other, which is very much like a window tumbling over and over along positive x-axis. Because they do not overlap, we can use the tumbling window to do many statistical analysis, which involves calculating summation, maximum, minimum, count, mean, etc. And therefore, this tumbling window has many application scenarios. For example, the BI statistics collection, real-time traffic volume analysis, page clicking analysis, and so on. Here is just one example showing how we can use tumbling window to do summations. The second type, sliding window. Again, the windows have the same length, but now they are allowed to be overlapping. And the length of the overlapped area is also determined by users. This type of window is like a window sliding along the time axis, and that is why it is called sliding window. We can still use sliding window to do some statistical analysis, but there might be some problems. For instance, in the example displayed below, some records are considered more than just once. So now, the result is not a classical summation of all records, thus it cannot be applied to traffic volume analysis, or else it will be larger than its real number. But there is a more suitable application scenario for a sliding window, collecting statistics of interface failure rate and then determine whether to report or not. In this case, the earlier failure might have impacts on the later one, and they have an accumulated results for the alarm threshold. Thus, we need more smooth transitions among different windows, and a sliding window just meets the requirement of the smoothness. The last type, session window. This type of window looks very different from the previous two types because now the window length is not fixed anymore. In order to use the session window, we need to define how long the period of inactivity is. Namely, a session window closes when it does not receive elements for a certain period of time. When this period expires, the current session closes, and subsequent elements are assigned to a new session window. And the most common usage of session window is the web application session analysis. And here, we can just have a look at how to define a window using the codes below. Now, the tumbling window length is 1 minute, so we can use time.minutes1 for configuration, which is all we need to do. But by contrast, for sliding window, we need to define the sliding period as 30 seconds, and that is why there are two parameters here. Okay, just now we mentioned a program called out of order, and we mentioned a mechanism called watermark. But what is a watermark? Now, in the third section, we can have a look at the watermark mechanism in detail.